Hi everyone. In this tutorial I'm going to help you get started with fluid simulation. If you watch some other tutorials on the internet and you follow the exact same steps, there will be no problem. But if you want to tweak things or make something that is a little bit different, you may face some issues. So in this tutorial I'm going to help you solve the most common issues. I'm using Blender version 3 alpha, and let's get started. I can set the default cube to be the flow object. I can make it the object that emits fluid. But this won't really help you because everything works fine with the default cube. We need an object that is a little bit more complex so that we face some issues and learn how to solve them. Anyway, let's try the default cube first. Go to Object menu, then Quick Effects, and then select Quick Liquid. As you can see, the fluid simulation works properly, so I'm not going to use the default cube in this tutorial. Let's delete all of these objects. My flow object will be a UV sphere. There is no need to use this much geometry, so I'm going to set both segments and rings to 3. Blender doesn't like small flow objects. Blender wants the object that will emit fluid to be big enough. So I'm going to scale it down to face some issues so we learn how to solve them. I'll set the radius to be 0.1. This is very small. If you haven't noticed, Blender jumps to wireframe mode when you add the fluid simulation. I'll go to this solid view again. Some people think that everything disappears when they add the fluid simulation, and that's not true. It just automatically switches to the wireframe mode, and you can switch it back to any other view you want. Let's add the fluid simulation to this object, and it'll be our flow object, so click on Object, Quick Effects, then Quick Fluid. Here is our domain. It is created around our object. Let's play the animation to see the fluid, and, oops, there is no water. A few seconds ago, we did the exact same steps with the default cube, and we were able to see some water, or some fluid moving. So what happened? This is our object that is supposed to emit fluid, and it is very small. That's why I told you that Blender doesn't like small flow objects. I already know the reason and the solution of this issue, because I've experienced it before. But in case you don't know the solution, the first step you need to do to troubleshoot the issue is to bake your simulation. Baking means that you apply the settings that may have not been applied yet, and save the calculations of each frame so you can play the animation in real time. So a common cause or a common reason for a lot of issues is that you may have forgotten to bake. You need to bake each time you update or change the settings of the fluid simulation. To bake the simulation, click on the domain. Then go to the Physics tab. Let's enlarge this a little. Scroll all the way down, and the Bake button is supposed to be under the Cache section, but it is hidden. To make it visible, you need to change the type, so instead of Replay, you should make it Modular or All. I'll choose All. Now we can find our cute Bake button. There is no need to bake the full range, so I'll change the end frame to be 150, then click Bake. After baking, all the settings are applied, all computations are done, everything should be ready. Let's try and play the animation. Still no water because the flow object is too small. You have two solutions. The first one is to scale up the object, which I don't recommend, because you may want to have a small flow object in your scene. Anyway, I'll try this solution, so I'll press S and scale it up to be 10 times larger. We need to bake again, because we made some changes or updates to the scene, so click on the domain, scroll down, click Free Bake to make Blender forget about the previous or old bake, because it is about the object when it was small, so we need Blender to forget the calculations of the previous settings. Let's click Bake again to recalculate our new changes. As you can see, there is water here. It works properly. But what if you want a smaller flow object? I'm going to free the bake. Then, I'll scale it down again so even if you bake there will be no water. The second solution is to select your flow object to be able to see its settings, unfold flow source. Then check, is planar. So this is the secret, if there is no water, try to check is planar. Don't forget to bake after you change the settings, so click on the domain and click bake. As you can see, we have water here, it works. This is a very small amount of water, because the flow object is small, but now it works properly. I want to animate the flow object, so I'll change the size of the domain. Let's free the bake. You can enter edit mode and edit the faces normally, as what you would do with any other object. I'll select the bottom face and move it up. And then select this side face and move it along the y-axis. I'll move the whole domain along the z-axis like this. Now I think it's time to animate our flow object, so I'll select the flow object, press N, hover over here and press I to insert a keyframe. Go to frame 41 for example, and then move it like that, then press I to insert a keyframe. We can make it stay there for a short time like 5 frames, so press I again. At frame 80, I want it to go back to its original place. Insert a keyframe. Here is the final animation. Let's bake our fluid simulation and see what happens. For your information, there are 2 types of fluid simulations. Flip produces a very splashy simulation. Epic produces an energetic, but also more stable simulation. Vortices within the liquid will be preserved better than with Flip. Also, I want to make my fluid viscous like chocolate. This can be achieved with viscosity, but I'll try the diffusion first, so I'll enable it, and click on this icon to find the 3 presets. You can choose between water, oil, and honey. The behavior of liquid chocolate is closer to honey's behavior, so I'll choose it. Before adding material and rendering, you will need to enable mesh. This will make the fluid particles appear as a mesh so it can be seen in the final render. Let's bake our new settings. I'll set the end frame of the animation to be 150, because the end frame of the simulation is 150. Here is our simulation. It works well, but it doesn't behave like honey or chocolate. It needs to be more viscous. And we still have a small amount of liquid that just drops down. It's just a drop, not a flow. So to solve this flow issue, select the flow object. For the flow behavior, we don't need the geometry option, because it will make it look like a drop. But we need inflow. By the way, if you choose outflow, the object will absorb liquid instead of emitting it. The liquid particles will disappear when they touch the outflow object, and the volume of the liquid will shrink. The outflow object works as a sink drain. So let's choose inflow so the object will continuously emit water, and if you want to stop the flow you can uncheck use flow. And this can be animated as well, and we will do it later in this tutorial. After changing the flow type to be inflow, let's bake the simulation, so where is our domain? We need to click on it to see its settings and bake. The domain now takes the shape of the liquid, because we previously enabled the mesh option. So you can click on the liquid, or you can click on the domain here. Let's free all and then bake it again. Now we have a flow instead of a small drop of liquid, and the flow works very well. You can also see it in the solid view mode. It looks like milk, but we still need it to be more viscous. Let's free all. I'm not going to use the diffusion and the honey properties. I'm going to use viscosity this time. I'll set it to be 0.2. Let's bake again. Wow, this has higher viscosity and behaves more like a liquid chocolate. So in my opinion, using viscosity is better than using diffusion. If you feel like the liquid is low poly, you can fix this by increasing the resolution subdivisions of the domain. Here it is. This is the number of voxels in the domain. You can also make the liquid smoother by going to the mesh settings and increasing the uppers factor. So I'll try uppers value of 4. Let's bake it again to see the difference. Well, the fluid now looks better or smoother, but I feel like it consists of cubes. I think that's because the resolution subdivisions value of the domain is low. The domain is subdivided into smaller cubes. Each cube is called voxel. The name voxel is short for volume pixel. If the size of voxels is big, you will see liquid as squares, so let's increase the resolution of our domain instead of increasing the resolution of the mesh, the uppers value. I'll free the bake. Then, I'll reset the uppers value to its default by hovering over it and pressing backspace. For the domain, let's increase the resolution division to 64. It'll make the liquid look smoother, but the baking time will increase. Let's play the animation. One more thing I would like to mention. CFL number is the accuracy of the simulation. A greater number means less simulation steps and less computation time, which is good. But this results in less physically accurate behavior for fast fluid flows. You may need to change it if you have a fast fluid flow, and especially if the fluid collides with an obstacle. If the simulation has a physically inaccurate behavior, then you should lower the CFL number. This leads to calculating higher simulation steps per frame, so you will get more physically accurate behaviors for the fast fluid flow. But this will increase the computation time, or the baking time. So, the CFL number is the accuracy of the simulation, and greater CFL number will minimize the number of simulation steps and the computation time, and may lead to less physically accurate behavior. You can also control the maximum and minimum number of steps per frame here. When lowering the CFL number, it is recommended to increase the maximum number of time steps. Similarly, when increasing the CFL number, the minimum number of time steps should be adjusted. Let's free the bake to be able to see the domain as a cube. This is the size of the domain, and it requires a resolution of 64 to produce a good-looking simulation. Here it is 64 subdivisions. What if you want to double the size of the domain while keeping the same quality? I press S then 2 to double the size. To keep the same quality, you have to double the resolution subdivisions as well. So we should make it 128 instead of 64. This will take longer to compute, so you will want to make the domain just large enough that the simulation will fit inside it, but not so large that it takes too long to compute the simulation. It is like Blender loves large flow objects, but hates large domains as they require high-resolution subdivisions. Also for the time scale, it controls the speed of the simulation. Low values result in a slow-motion simulation. If you want to render a still image, if you don't want to render a video, then you can use higher values to reach the end of the simulation faster. You can change the particle radius whenever the simulation appears to leak or gain volume in an undesired, non-physically accurate way. When liquid seems to disappear, this value needs to be increased. When too much liquid is being produced, this value needs to be decreased. I'll go to wireframe mode to be able to select the flow object because I want to animate its flow behavior. I'll make the flow stop or pause for a while and then continue. I want it to move like that and emits fluid until it reaches frame 41. This is the last frame to emit fluid, so I'll insert a keyframe here. At frame 42, I need to stop the flow, so I'll uncheck Use Flow, then insert a keyframe. Then, I want the flow to stop for a while. There will be no fluid until frame 58. So, I'll keep Use Flow unchecked and insert a keyframe. I need the flow to start again at frame 59, so I'll check it and insert a keyframe. So the flow will start from here to the rest of the animation. Let's bake it to see how it looks like. Blender crashes because I have too many resolution subdivisions. I forgot to lower this number. I'll make it 32. And I'll scale down the domain. This time it'll bake faster and no crash will occur. As you can see, the flow stops during the period that we specified. The flow stops and starts again. I'll select the flow object so you can see the keyframes. The flow stops from this keyframe to this keyframe. I hope you enjoyed this tutorial. For more tutorials, don't forget to subscribe. Good luck and have a nice day.